Yeah, please start.
So, good evening, everyone. Today we are going to discuss about singleton design pattern. Okay. So, let us start the session. So, this is agenda, definition, creational design pattern, advantage and usages of singleton design pattern, implementation of lazy instantiation, implementation of eager instantiation, thread safe singleton in Java, and finally double check logging implementation. So, these are the things we are going to discuss one by one in the upcoming slides. So, this is definition. So in this slide, I have given what is singleton design pattern. Okay. So singleton design pattern ensures that a class has only one instance and to provide a global point to access this instance. So in other words, a class must ensure that only single instance should be created and single object can be used by all other classes. Okay. So this singleton design pattern ensures that a class should have only one instance and it should also provide global access point to access the created instance. Okay. So basically there are two forms of singleton design pattern. So one is early instantiation. So it means it will create the object at the time of class loading. Okay. So one more thing about this early instantiation means, so this is the easiest method to create a singleton class. Okay. So second one is lazy instantiation. So which means it will create the instance when it requires. Okay. So in the upcoming slides, we will discuss little elaborately about these two forms. Okay. So this singleton design pattern comes under creational design patterns category. So in the next slide, we will discuss briefly about what is creational design pattern. So this is creational design pattern. So creational design pattern that deals with the creation of an object. This design pattern is one category among the GOF design patterns. So this creational design pattern mainly deals with the object creation. So this is one of the category among the GOF design patterns. So GOF design pattern is nothing but gangs of four design pattern. So these gangs of four design patterns are divided into three categories. So first one is creational, second one is structural, and finally behavioral. So our singleton design pattern comes under the creational category. So there are totally 5 design patterns in the creational design pattern. So first one is singleton, factory, abstract factory, builder, and the final one is prototype. Okay. So these are the design patterns which comes under the creational design pattern. So this is the brief description about the creational design pattern. So this is singleton instance across JVM and the Tomcat server. So in this slide, we will see how the singleton instance works in sorry, how the singleton instance works across JVM. Okay. So a singleton is a class that is supposed to have only one instance per class loader per JVM. The same instance of the singleton class is reused by multiple threads. Okay. So here we should have only one instance per class loader per JVM so that it will be reused by all other threads. Okay. So most often this singleton will be used to represent system configurations and the Windows managers, since those instances should be common to all threads and the objects within JVM. Okay. So now we will see how this singleton instance works in Tomcat server. So for example, let's say we have two web applications where we have a singleton class. Okay. So let me tell once again, we have a two web applications where we have a singleton class. And if we are running two instances of a web application into Tomcat server, then we will get two different instances of the singleton class that is JV running in the Tomcat server. Okay. So this is because we stored the singleton class in each separate web application. But if our web application will use a singleton class from JRE or Tomcat shared libraries, then we will get the same instance of the singleton class. So in this case, single instance will be used for multiple instances of the same web application. So this happens because Tomcat server uses individual class loaders for web applications. So when a web application class loader needs a class, it will first try to find it in the class path. So if it cannot find, then it will ask its parent class loader to find the class. So this is the way how singleton instance works in Tomcat server. Okay. So this is advantages and the usages of singleton design pattern. So in this slide, I have given some of the advantages and the usages of the singleton design pattern. So let us see the advantages first. So singleton design pattern saves memory because object is not created at each request. Only single instance will be reused again and again. Okay. So in this slide, So sorry. So here we are not going to create object at each request. Only one object will be created, and the created object will be reused again and again. Okay. So that this singleton design pattern will save the memory. So second advantage is instance control. Singleton prevents other objects from instantiating their own copies of the singleton object, ensuring that all the objects access the single instance. Okay. So here it will restrict the instances of a singleton class, and it ensures that single instance will be used by all the objects. Okay. So this is usages of singleton design pattern. So singleton pattern is mostly used in multi-threaded and database applications. So while using multi-threading, if we want to manage the multi-thread pool, we can go for a singleton design pattern. Okay. So second usage is it is used in logging, caching, thread pools, configuration settings, etc. Okay. So this pattern is also used for logging framework implementation and caching implementation, and for configuration setting also we can use this design pattern, this singleton design pattern. So also this singleton design pattern is used for database connection, because one connection is enough for most applications, and too much connections can make applications slow. Okay. So if we have multiple connections for single application, it will reduce the application performance. So better we can use the singleton class for obtaining the database connection. Okay. So this is usage example. So in this slide, I have given a real-time usage example. Okay. So let's consider we have a music store in our iPod. Okay. So that has many categories like melodies, rags, devotional songs, pop songs, etc. So these melodies, rags, devotional songs, pop songs are the classes which are going to implement the interface. Okay. So this interface has a method called play. So if user one wants to play this pop songs means, okay, first the user one access the music store singleton class, and the singleton class will return one instance. So with the help of acquired instance, we can invoke the method and play our desired songs. So let's say next time user two would like to play rock songs means user two will not be allowed to create new instance. Instead, he will get the same instance which previously used by user one. Okay. So in the next slide, we will discuss with the sample code. So as I told you earlier, this is the interface iMusic action. Okay. So which has a method called play. So these are the classes pop songs and the devotional songs which are going to implement the above interface iMusic action. Okay. So this is this is music store class. If we want to make this music store class as singleton, we should follow some common steps. Okay. So the first step is create private static instance of a class. Okay. So second step is make constructor of this music store class as private. Okay. So here we can ask why we should make this constructor as private, because we don't want to create the object of music store class anywhere. Okay. So the third step is create public static method. Okay. This one. So create public static method. So here I have created get instance method which will return the instance for the music store class. So also I am having two methods, get pop songs and get devotional songs. So this is test class music executor. So in the main method we will not be able to create the instance for the music store class. Only we can get its instance because we made constructor of music store class as private. Okay. So music store dot get music instance. So this get music instance method will return an instance for the music store class. Okay. So we can call this get music instance with the class name music store, because this get music instance is a static method. Okay. So if we are going to get one more instance means we will get the same instance which was previously used by music instance one. Okay. So in the below output we can see two different objects, music instance 1 and music instance 2, both are same. So this is Java singleton pattern implementation. So to implement a singleton pattern, we have different approaches, but all of them have the following common concepts. Okay. So as I told earlier, if we are going to implement singleton pattern means we should follow some common steps. Okay. So the step one, make constructor as private. So we should make our constructor as private. So the second step is make a private static instance of class, but do not instantiate it. Okay. We should create private static instance of a class. Make sure we do not instantiate that instance. So third step is write a static method that checks the static instance member for null and creates the instance. So we should also create one public static method that will check static instance for null. So if it is null, it will allow to create the instance. Otherwise, it will simply return the object which was previously created by the previous one. Okay? So these are the common steps which are used to implement the singleton pattern. So this is implementation of lazy instantiation. So in this slide, we will see how to implement lazy instantiation, and also I have given implementation example for this method. So in this lazy instantiation method, it will create the instance when it requires. And this lazy instantiation method is also very common implementation of singleton, but it is not suitable for multi-threaded applications. Here we can ask why it is not suitable for multi-threaded applications. Because there is a possibility that multiple instance can invoke this get instance method. Okay. So if this get instance method is invoked, it will create multiple instances. So here we cannot achieve that singleton here. Okay. So that's why this method is not suitable for multi-threaded applications. So this get instance method is used to create the instance for the singleton class. Okay. So initially it will check the static instance for null. If it is null, it will allow to create the instance for the singleton class. Otherwise, it will simply return the object which was previously created. Okay. So this is the test class singleton test. So as I told earlier, in the main method, we will not be allowed to create the instance for the singleton class. Okay. So we can get only its instance because we made a constructor of singleton class as private. So here we are going to get three objects, object 1, object 2 and object 3 for the singleton class. So here I am having one nested if condition to check the object equality for the objects. Okay. So in the below output we can see those three objects are same. Okay. So this is implementation of eager instantiation. So here we are going to see how to implement eager instantiation and what are all the drawbacks of this method. So this is also one of the method in singleton design pattern. In eager instantiation, the instance of the class will be created at the time of class loading. Also, this is the easiest method to create a singleton class. So this method has some drawbacks. That is, instance of the class will be created even though client application may not using it. Okay. So also this method is not suitable for multi-threaded applications. This is not also this is not thread safe. This method is not thread safe. So if we are going to work in a multi-threaded environment means, then we should not go for this method. So if our singleton class is not using lot of resources, then we can use this implementation. Okay. But in most of the scenarios, singleton classes will be used for resources such as file system, DB connection, etc. So one more drawback is this method doesn't provide any options for exception handling. So this is all about eager instantiation. So this is static block initialization. So the static block initialization implementation is almost similar to eager initialization, but the difference is in the static block initialization method, the instance of the class will be created in the static block. That will provide the option for exception handling. So if there is any exception during the instantiation, it will be handled in the static block. So whereas the previous eager instantiation method doesn't provide any option for exception handling. So here also instance of the class will be created before it's being used. Okay. So this is all about static block initialization. Okay. So this is thread safe singleton in Java. So in this slide, we are going to see how to create a thread safe singleton class. So the easier way to create a thread safe singleton class is to make the global access methods synchronized, so that only one thread can execute this method at a time. Okay. So if we want to make this singleton class thread safe, we should make the get instance method synchronized. So here, synchronized is the Java keyword which is used to create the synchronized code. Also, this synchronized keyword internally uses locks on object or class to make sure only one thread is executing the synchronized code. For example, let's say two threads T1 and T2 both are calling the method get instance, okay, and trying to create the object at the same time. So both the threads T1 and T2 will reach the get instance method, and one thread will acquire the lock among them. Okay. So let's consider T1 will acquire the lock means T2 needs to wait. So that T1 will create the object and it will be initialized. So that T2 when it enters the get instance method, this if condition becomes false and it comes out and return the instance which was created by T2. Okay. So this implementation works fine and also provides thread safety, but it will reduce the performance. So because of the cost associated with this synchronized keyword. Okay. So just imagine if this get instance method is a non-static method, means this execution will take 1 millisecond. Okay. So but making this method synchronized will take 100 milliseconds. Okay. So this is the issue with this synchronized method. So to avoid this issue, we can use a double check locking method. So this is double check locking implementation. So in this double check locking approach, the synchronized block is used inside the if condition with an additional check to ensure that only one instance of a singleton class is created. So double check means here we will check the static instance for null 2 times. So one will simply check the instance at the beginning of the get instance method, and another one is inside the synchronized block. So let's say two threads T1 and T2 are calling the method getInstance and try to create the object at the same time. So both the threads T1 and T2 will reach the getInstance method and it checks the static instance for null. Since we are obtaining the lock on the Singleton class, only one thread will enter the synchronized block at a time. So the first thread enters and create the object, then leaves from the synchronized block. Then second thread enters the synchronized block and it finds this instance is not null. So it comes out of the block and return the object which was previously created by first thread. Okay. So this is all about double check locking implementation. So also this method will provide the thread safety. So we can use this if we are working in a multi-threaded environment. We go for this method. So this is key points to remember. So here I have given some of the key points of the singleton design pattern. Okay. So singleton design pattern lists the instantiation of a class and ensures that only one instance of the class exists in the JVM. The singleton class must provide global access point to get the instance of the class. So yeah, singleton is a class that is supposed to have only one instance per class loader per JVM. And finally, singleton pattern is also used in other design patterns like abstract factory, builder, prototype, packet, etc. So that's all from my side.
Okay. So you explained that concept which I mentioned, like whether it is the scope of a singleton, whether it is a JVM level or a class loader level. Hello, can you hear me?
Yes, sir, I can hear you.
So were you able to find that?
Sir, I need to
Pardon?
check one second, sir. I need to
Pardon?
check one second, sir. I need to check one second, sir. I need to refer one second.
Okay, so just find that because that's important to
Yes, sir.
understand the singleton. Okay, and can you go back to the previous slide? Yeah, here, what happens if the second if condition is not there? What will be the problem? The if
So
condition
first
within the synchronous block, if it is not
block.
there, yeah.
So let's say it's there are two threads, T1 and T2.
Mm-hmm.
First, both the threads will reach the get instance method,
Mm-hmm.
and both the threads will enter this instance, this if block, first if condition.
Mm-hmm.
So initially both the threads will be null. So it will enter. So this both threads will reach this synchronized.
Yes.
So here one thread will acquire the blocks.
Mm-hmm.
Okay, so then uh, so here as you said here the if condition is not there, so it will create the object.
Okay, the
So
first one will
so
create the.
both the threads will create the objects actually.
Okay, okay. Sure. Anyone else has any questions?
No, sir.
Okay.